All right, here is the lymphatic system. This video is going to be just the lymphatic, and then we'll keep the immune separate. So the first thing that you want to know is actually an open-ended question, be able to describe the two functions of the lymphatic system. So this is returning interstitial fluid, or what is sometimes called the lymph, back into the bloodstream, and then providing a structural home for the immune system. So the way it works is that your capillaries, which the blood flows through, are all quite permeable, so lots of fluid leaks out of all of your capillaries. That fluid, if it weren't returned to the bloodstream, would just accumulate in your tissues and we would all be all swelled up all of the time. So as the lymph flows through your lymphatic system, it also flows through lymph nodes, which is where your lymphocytes, some of your white blood cells, spend a lot of their time. And that's what comprises your immune system, is your white blood cells. So your lymphatic system is also where your immune system lives. For lymphatic capillaries, what you want to know about them is that they are very permeable. You want them to be permeable because the pressure in your lymphatic system is basically zero, so you're relying on the muscular pump and the respiratory pump, just like from the veins, to milk the lymph back towards the subclavian veins. That's where it's going to re-enter the bloodstream. So you want it to be real easy for lymph to get into lymphatic capillaries. One of the ways this happens is through what are called endothelial flaps, or some other books call them mini valves. And it's hard to see with these pictures here, but like right there, the cells overlap one another a little bit, but they're not firmly connected, so that they can actually come apart and fluid can get in. And fluid can get in, but it can't get out very easily. So they're kind of like carabiners, or like a safety clip, which is hard to open. You can push in, but it doesn't pop out. And then you just want to know what a lacteal is, which is a lymphatic capillary that you find in your intestines. These are there so that you can absorb your dietary fats. This slide, not important, we already talked about it. You do want to know that your lymphatic vessels have valves, like your veins, and as I said, it relies on the respiratory and the muscular pump to get the lymph back to the circulatory system. Then we have the basic description of the drainage of your lymphatic system. And it's organized sort of the way this figure here is color-coded, where the right half of your torso and the right half of your head all empty into the right lymphatic duct, and then the rest of your body, which is all yellow here, all drains into the thoracic duct. It would be nice if we called it the left lymphatic duct, but the reason why this thing right here is called the thoracic duct is because it's continuous with this green part here. So it runs through the whole thorax and empties in right here. So as you can see, the right lymphatic duct and the thoracic duct both empty the lymph, or drain the lymph, into the venous system right where your internal jugular and subclavian vein meet. So all of that lymph has to get all the way up to above the heart before it can re-enter the bloodstream. Next up is lymphatic tissue, or lymphoid tissue. What you want to know is that architecturally it is composed of what is called reticular connective tissue. And when you look at it under the microscope, you can see the circular structures that are lighter in the middle and darker on the outside. Those are called nodules. We don't look at lymphatic tissue under the microscope in here, but if you're looking at slides under the microscope and you see something that looks like that, you know you're looking at lymphoid tissue. So how reticular tissue is organized is you can kind of think of it almost like your Brita water filter. Water trickles through the Brita filter, and as it flows over all of the charcoal pulls impurities out of the water. For your reticular tissue, you have, in purple here, are the nuclei of all sorts of lymphocytes, macrophages, and reticular cells. Only instead of being contained in like a little baggy mesh thing like your Brita filter, all of the cells are held together by a scaffolding of reticular fibers, and that's what the reticular cells do. But fluid trickles through your lymphatic tissue and runs over all of those cells, and the macrophages clear out debris, bacteria, viruses, dead red blood cells, and then your lymphocytes, B lymphocytes and T lymphocytes, are monitoring the lymph for signs of infection and responding to infection. This will go through kind of quickly because we have the rest of the chapter to talk specifically about T cells and B cells. For now, you want to think of T lymphocytes as being primarily adapted to help fight viruses. They do a lot more than that, but for right now, that's the thing that's easiest enough for file away in memory. And then the B cells are the lymphocytes that are going to secrete antibodies. Macrophages and reticular cells you are already familiar with. So then, as we go through the lymphatic system, we are going to have different types of lymphatic tissue. We are going to have discrete lymphatic organs. These have a capsule around them, and you can point at them and identify them easy. And then there is what is called diffuse lymphatic tissue, which is reticular tissue or lymphatic tissue that you find embedded within other tissues. For example, here, this is a picture of lung, and here you can see this lymphatic tissue looks a little bit like a lymph node. That is some diffuse lymphatic tissue. So we're going to start by going through the discrete lymphatic organs and then talk about a couple different types of diffuse lymphatic tissue. First up are the lymph nodes. I do believe that, sorry, I have to check the, what are those things called? Objectives to make sure, no, this is not an essay question. Good, because it confuses people. So the lymph nodes, as it says right here, you do want to know their function. This is where the lymphocytes spend most of their time, so that is when we say the lymphatic system houses the immune system. It is housed mostly within your lymph nodes, and as the lymph flows through your lymph nodes, it is filtered and monitored. So the macrophages destroy and phagocytize debris and microorganisms and dead red blood cells. What else do we want to know? This slide right here is a possible open-ended essay question. So you have lymph nodes scattered throughout your body. A lot of them are deeper within tissues, so you can't palpate them or feel for inflammation near the surface, but there are 3 regions of your body that have high concentrations of lymph nodes near the surface, so you just need to be able to list them. They are the inguinal region, the axillary region, and the cervical region. So your groin, your armpit, and your neck. And like if you go to the doctor and you think you're sick and the doctor is feeling your neck, she or he is really feeling for lymph nodes. So when they say swollen glands, they're looking for swollen lymph nodes, because if you have an infection, your lymphocytes are going to multiply, and because they live primarily in your lymph nodes, so your lymph nodes can swell. Then we are on to the spleen. All we're going to worry about for the spleen is that this is primarily where dead red blood cells are removed from the bloodstream. It does other things, but we're going to keep it simple. Then the thymus. This you just want to know is the site of T lymphocyte maturation. And we will go into what that means when we cover T lymphocytes. But your immune cells, T cells especially, are capable of killing your own cells if they become a liability. So you want to make sure you have good quality control over lymphocytes before they are released into the bloodstream. So that's what the spleen does, is quality control on T lymphocytes. Then tonsils. These, as it says right here, are found in your pharynx. That is just the back of your throat. So pharynx is anywhere that air and food or air and water might mix, right? It's everything above where your windpipe and your food pipe diverge. What it is thought they do, or how I understand what they do, is that they're, again, lymphatic tissue that's in your mouth. Most of what is in your mouth is going to hit your stomach, which is a pit of acid, and 9 times out of 10, any bacteria or viruses in your food, if they're not dead from being cooked already, are going to be killed in your stomach. What your tonsils do is allow your immune system to be exposed to pathogens before those pathogens show up in your bloodstream. So they're letting your immune system get a glimpse of potential infectious agents before there's an infection. And that helps develop immunity or immune memory, which we'll go into when we do the immune system later in the chapter. Then you have the appendix. This is your appendix right here. It is a little finger-like projection that comes off the bottom of your large intestine, or this little pouch of your large intestine called the cecum. What it is thought to do, as this says right here, is to house good bacteria. So the more and more we're learning about your microbiome, or all of the microorganisms that live in and on your body, we're learning that they have a big impact on homeostasis, your health and well-being. So you have a lot of bacteria that live in your large intestine, and for the most part your body's used to them and they do good and you want to have them there. But if you have something like the flu, which may cause diarrhea, right, your large intestine is going to empty out. And that bout of sickness might even alter the population of bacteria that you find in your large intestine, and alter it for worse. So what your appendix does is allow for recolonization of your large intestine following a bout of sickness with the good bacteria that are supposed to be there. Now we are into diffuse lymphatic tissue, which is really the only kind of diffuse lymphatic tissue we are going to talk about is MALT, which stands for mucosa-associated lymphatic tissue. So you find it within your mucous membranes. So the one example of MALT, which we are going to name specifically, are the Peyer's patches. As it says here, it's lymphatic tissue and it's found within the small intestine. So it's embedded in the mucous membrane of your small intestine, and your lungs are also, what's the word I'm looking for, lined or composed of mucous membranes. So here is a lymphatic follicle in somebody or something's lungs, which we would refer to as MALT, or mucosa-associated lymphatic tissue. We are going to leave it there, and there will be a separate video for the immune system itself.